Have we finally uncovered signs of life on Mars? NASA's Perseverance rover has sent back an image that has scientists and space enthusiasts buzzing with excitement. This isn't just any rock, this might be the rock that changes everything we know about life in the universe. Join us as we explore this groundbreaking discovery, its implications for humanity, and how Perseverance is rewriting the story of Mars. Buckle up, because what you're about to learn will blow your mind. Could this mysterious rock finally answer the age-old question about life beyond Earth? NASA's Perseverance rover has uncovered a peculiar rock on Mars, and its findings could rewrite what we know about the red planet and the possibility of extraterrestrial life. The rock in question features striking dark-bordered patterns, rich in iron and phosphorus. On Earth, similar formations, often called leopard spots, are typically the result of microbial activity. Could this be evidence of Martian microorganisms? Have we stumbled upon the long-sought inhabitants of Mars? But that's not all. Recent discoveries reveal a massive underground reservoir of liquid water on Mars. Scientists believe this hidden aquatic world might provide the perfect conditions for life to thrive, even today. So, what does this mean for the search for life on Mars? And how does Albert Einstein's theory of relativity tie into all this? Believe it or not, the rock's name, Einstein SL, has the scientific community buzzing. Jokes aside, the implications of this discovery are truly groundbreaking. The question remains, where did all that water go? Contrary to earlier theories, a groundbreaking new study suggests that Mars's water hasn't vanished into thin air. It's still there, hidden underground. But more on that later. For now, Perseverance is focused on its mission to investigate the ancient river delta within the Jezero crater. Its goals? To collect material samples for eventual return to Earth and search for potential signs of past Martian life. As of July, NASA has hinted at exciting developments. Could this be the breakthrough moment in the quest to uncover Mars' secrets? Stay tuned as Perseverance continues its historic mission to unveil the mysteries of the red planet. This year, the Perseverance rover may have struck gold Mars style. On the northern edge of the ancient Neda River Valley, it discovered an unprecedented rock formation that had never been seen before on the red planet. The star of this groundbreaking find is a rock roughly 1 meter long and 60 centimeters wide, which the team has named Shava Falls. What makes it so captivating? The rock is adorned with strange, tail-like traces. Among them are broad, white sulfate veins, with darker reddish materials slumbering between them, hinting at the presence of hematite. While iron oxide, hematite, is not uncommon on Mars, the real mystery lies in the tiny, irregularly shaped white spots embedded in the dark hematite deposits. These spots are only a few millimeters in size, but what truly sets them apart is their surrounding rings of black material. These rings are rich in iron and phosphate elements that, on Earth, are commonly associated with life. It may sound like a simple list of geological components, but to experts, this find is anything but ordinary. Ken Farley from the California Institute of Technology has said that these traces could be one of the most enigmatic and important discoveries yet on Mars. Could these peculiar formations point to something more like microbial life from Mars' distant past? The excitement in the scientific community is palpable, and this rock may just be the key to unlocking the planet's deepest secrets. The California Institute of Technology has made a bold statement. Shava Falls could be the first definitive evidence of organic material on Mars. But that's just the beginning of the excitement. Ken Farley, who helped make the discovery, goes even further, calling it the most enigmatic, complex, and potentially most important rock that Perseverance has ever studied. Why all the hype? Because those strange, colorful leopard spots on the rock could point to chemical reactions linked to microbial life. Spectrometer tests revealed something extraordinary. The spots, along with their surrounding material, contain organic carbon compounds. When combined with the iron and phosphates present, these findings strongly resemble patterns of microbial activity seen on Earth. On our planet, similar spots are often created by microbes that leave behind fossilized remains, locked away beneath the surface. What makes this even more thrilling is the fact that Chava Falls was once part of a much wetter environment. Billions of years ago, an ideal setting for microbial life to thrive. Could this rock be the key to answering one of humanity's oldest questions? Was there ever life on Mars? Perseverance's discovery may have just brought us one step closer to answering that question. The implications are nothing short of revolutionary. Is Earth the only place in the universe where life exists? While we may wish for a definitive answer, the truth is a bit more complex. Organic molecules, which are often associated with life on Earth, can also be created through non-living geochemical processes, no bacteria required. For instance, we know that volcanic activity can generate such compounds. This brings us to the mystery of Chava Falls. If the rock was heated by volcanic lava, it would force us to reconsider the possibility of Martian life. In fact, a mineral grain called olivine, commonly found in magma, has been detected in the rock, further complicating matters. But here's the catch. The presence of volcanism doesn't rule out the possibility that those leopard spots were formed by ancient Martian microorganisms. The plot thickens. Chava Falls, with all its unanswered questions, still holds many secrets. However, researchers admit that we've hit a bit of a roadblock. Remote sensing methods, which have allowed us to study the rock from a distance, have largely reached their limit. So while the rock may hold the potential for groundbreaking discoveries, it looks like solving this mystery will require more than just observations from afar. For now, the enigma of Chava Falls continues to captivate scientists and could keep us on the edge of our seats for years to come. ENASA's Perseverance rover, launched in July 2020, landed on Mars in February 2021. Its primary mission? To search for signs of ancient life in the Jezero crater, an area scientists believe was once home to a lake. Equipped with cutting-edge instruments, Perseverance can analyze soil, rocks, and the Martian atmosphere in incredible detail. But beyond the science, the rover represents humanity's hope to answer one of the most profound questions. Are we alone in the universe? The Jezero crater was chosen because of its rich geological diversity. If life ever existed on Mars, it might have thrived in this region billions of years ago when the planet was warmer and wetter. Perseverance's ability to collect and store rock samples for future return to Earth marks a monumental step forward in astrobiology. Recently, Perseverance captured the image of a peculiar rock that stood out among Mars's otherwise barren landscape. This wasn't just any Martian stone. It had distinctive patterns and textures that hinted at a biological origin. Researchers suspect these markings could be evidence of microbial life that existed billions of years ago. Even more intriguing, the chemical composition of the rock contains organic compounds, key building blocks of life. While these compounds can also be produced through non-biological processes, their presence in such abundance within the Jezero crater has raised eyebrows. Is this proof of ancient Martian microbes? While the evidence is compelling, scientists remain cautious, stressing the need for further analysis. Perseverance isn't just a rover, it's a mobile science lab. The robot uses an instrument called PIXL Planetary Instrument for X-ray lithochemistry to conduct detailed chemical analyses of Martian rocks. PIXL can detect minute traces of elements that might be linked to biological activity. Another tool in its arsenal is the SHERLO, scanning habitable environments with Raman and luminescence for organics and chemicals instrument. SHERLO uses ultraviolet lasers to identify organic compounds and minerals. Together, these tools are revealing Mars's geological history while hunting for signs of life. The rock in question was extensively studied using both PIXL and SHERLOC, and the data strongly suggests it warrants closer scrutiny. If this rock indeed contains evidence of ancient life, the implications are staggering. For starters, it would prove that life is not unique to Earth. This could mean life might exist or have existed elsewhere in our solar system, like Europa or Titan. It would also raise philosophical and scientific questions about the origins of life. Would discovering Martian microbes suggest a shared ancestry with Earth's life forms? Or would it indicate that life can arise independently under the right conditions? Either way, such a finding would revolutionize biology, chemistry, and even space exploration. It might also strengthen humanity's resolve to explore beyond our home planet, pushing for missions to more distant worlds. The discovery of this rock is just the beginning. Perseverance is scheduled to continue its exploration of the Jezero crater, analyzing more rocks and collecting samples. These samples are set to be returned to Earth by future missions for deeper investigation, a feat never before attempted in planetary exploration. Additionally, ENASA is working on sending the first crewed mission to Mars in the 2030 ES. By then, discoveries like this rock could guide where humans might land and what to study. For now, scientists remain cautiously optimistic, awaiting more data to confirm or refute the possibility of ancient life on Mars. The Jezero crater wasn't chosen randomly. Scientists believe this ancient basin held a river delta around 3.5 billion years ago. River deltas on Earth are hotspots for preserving organic material because sediment can bury and protect it from degradation. Analyzing the crater's layers allows scientists to reconstruct the environmental history of Mars. If microbial life existed in the past, this area might reveal the chemical fingerprints of its presence. With Perseverance roaming this fascinating region, every rock holds the potential to unveil Mars's biological past. Water is essential for life as we know it. Evidence from previous missions shows Mars once had vast rivers, lakes, and even oceans. But where did all that water open? Subsurface regions, shielded from the planet's harsh radiation, might harbor reservoirs of liquid water. Future missions could explore these underground regions. For now, Perseverance's findings could offer clues about what modern Martian life might look like or how to detect it. Organic compounds are carbon-based molecules that form the foundation of life. While Perseverance has detected these compounds in Martian rocks, their presence alone doesn't confirm life. Scientists must differentiate between biological and iotic origins of these compounds. For example, volcanic activity can create organics without any biological involvement. By analyzing the surrounding environment, Perseverance provides critical context to make this distinction. Perseverance's exploration is supported by its trusty companion, the Ingenuity helicopter. This small drone has conducted several successful flights, scouting areas that Perseverance might investigate. Ingenuity's aerial perspective helps identify promising locations for study, like areas rich in sedimentary rocks. This partnership showcases how innovation in robotics enhances our ability to explore distant worlds. Despite the excitement, ENASA scientists emphasize caution. Interpreting the chemical signatures of ancient life is incredibly complex. False positives could arise from chemical reactions unrelated to biology. This is why Perseverance collects and stores rock samples. Bringing them back to Earth will allow scientists to use advanced lab techniques unavailable on the rover, ensuring more accurate conclusions. Mars sample return missions are crucial to confirm life's existence. Perseverance has a sophisticated caching system that seals rock samples in sterile tubes. These tubes will be retrieved by future missions planned by NASA and the European Space Agency, ESA. Once back on Earth, scientists can use high-resolution microscopes and isotopic analyses to uncover secrets hidden within these Martian rocks. On Earth, microbial life thrives in extreme environments, from deep-sea hydrothermal vents to Antarctic ice. This resilience suggests life could also exist in Mars's harsh conditions. By studying Earth's extremophiles, scientists gain insight into the kinds of life forms that could have inhabited Mars. This knowledge helps guide Perseverance's investigations. If life is discovered on Mars, one key question will be whether it shares a common origin with life on Earth. Some theories suggest life might have traveled between planets via meteorites. Alternatively, life could have arisen independently on Mars. Either scenario would provide profound insights into how life begins and evolves, reshaping our understanding of biology. A discovery of extraterrestrial life could have immediate consequences for space exploration funding. Governments and private entities might increase investments in missions to other planets and moons. This boost could accelerate timelines for ambitious projects, like sending humans to Mars or exploring the icy moons of Jupiter and Saturn, where life might also exist. How would humanity react if we found evidence of life on Mars? The discovery could inspire awe and wonder, uniting people in the pursuit of knowledge. However, it might also raise ethical and existential questions. How would this affect our religious beliefs, our perception of Earth's uniqueness, and our role in the cosmos? Artificial intelligence plays a critical role in Perseverance's success. The rover's onboard AI helps it navigate tricky terrain, choose promising rocks for study, and even manage data transmission. AI will continue to be vital in future missions, enabling robots to perform complex tasks and make autonomous decisions on distant planets. Perseverance's mission isn't just about studying the past, it's also preparing for the future. By analyzing Mars's soil and atmosphere, the rover gathers data essential for human exploration. For example, the MOXIE instrument aboard Perseverance produces oxygen from the Martian atmosphere, demonstrating technology that could support human colonies. As we search for life on Mars, another concern arises: the risk of contamination. Could Earth microbes hitch a ride on our spacecraft and interfere with Martian ecosystems? NASA follows strict planetary protection protocols to minimize this risk, ensuring our search for life remains uncontaminated by our presence. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.